This will be solutions to section 3.5. Section 3.5 is implicit differentiation. So section 3.5, implicit differentiation. So in this section, we're going to focus on how to take the derivative of an equation when we can't solve that equation for y. We cannot explicitly write the equation as y equals and have all of our dependent variables on, all of our independent variables on the right-hand side. So we'll take a look at a question. I'll start with something like question 6. Question 6 is 2x cubed. Now that's just an expression in x plus x squared y minus xy cubed equals 2. Okay, so this is a very classic implicit differentiation type problem. We cannot solve this explicitly for y. We can't get y equals and get every other term to the other side. Algebraically, it's beyond our ability. It's either impossible or not something that we even want to try to tackle. Now, one of the things that we need to pay attention to in problems when we get to explicit differentiation is we have to pay attention to the fact that this term right there is a product. So we are going to have to use the product rule when we take the derivative of that term. This term right here, likewise, is a product. So we're going to have to make sure when we're taking the derivative that we utilize the product rule. So we're going to take the derivative. Now, our independent variable, according to our instructions here, is they want us to find the derivative with respect to x. So we're going to find the derivative with respect to x of the first term. Using our differentiation rules, this is a sum. So the derivative of a term plus another term is going to be the derivative of the first term plus the derivative of the second term minus the derivative of the third term equals, and then we take the derivative of this side as well. So we're going to utilize, we're going to utilize the derivative of the sum and difference rule first. Now, where do we go from there? Well, our next step is going to be to take these derivatives. Here, we're taking the derivative with respect to x of 2x cubed. There's no y here. This is the derivative with respect to x of a term that is expressed explicitly in x. So we just follow our derivative rules. We know if we take the derivative of a constant times a function, it's going to be, we get the constant out in front. The derivative of x cubed is going to be 3x squared. So that term, the derivative of that term, is very similar to all the derivatives we've taken up until this section. Now, when we get to the next term, we're going to have to remember here that this is a product. This is our function f, and this is our function g, if we want to think about that in terms of f times g. When we take the derivative of a product, the product rule says you take the derivative of the first term, right? The product rule was f prime times g. So I take the derivative of x squared. That's going to be 2x. I multiply that times my second factor, my second factor is going to be g, which in this case is y, so I just multiply. But we're not done, right? Because the product rule has another part. We leave f alone and we take the derivative of g. So we leave f alone, so plus, right? Product rule plus. We put our x squared here, and now we have to take the derivative of y. Now, it's very important for us to remember that we're taking the derivative with respect to x. So the derivative of y with respect to x is not 1, even though that's y to the first power. The derivative of y with respect to x is just the derivative of y with respect to x. It's y prime. We don't use that notation y prime. This is another notation for y prime. Back in the day, we said, well, some of the notations for derivatives that we're going to encounter, we're going to say f prime of x. That means the derivative of f. We could call that y prime derivative. And another term we said was we could say dy dx. They all mean the same thing. When doing implicit differentiation, we have to remember that when we take the derivative of y, we do not get 1. We get the derivative of y. Now here we have a minus sign, so I'm going to put that here. I'm going to put the bracket out here to make sure I distribute the minus to the two terms, because again, we have a product rule here. Again, this is going to be f, and this is going to be g. Now, I take the derivative of the first term. The derivative of x is 1. I'll go ahead and write it down just so we can have completeness in our expression here, but we don't have to write that. Now we leave g alone, so that just becomes y cubed plus product rule. We leave the f alone, that's x. Now we have to take the derivative of y cubed. Now, if we're going to take the derivative with respect to x of y cubed, if we write it like that, we have an inside function of y and an outside function of the cube. Now, the chain rule says we take the derivative of the cubic, so that's going to be 3 times whatever that was squared, right? And we leave the y alone. But we're not finished. The chain rule also says we have to take the derivative of what we find inside. What we find inside is y, so we're going to have a factor of the derivative of y. So we're going to get our x, we leave that alone, and then we get 3y squared dy dx equals the derivative of 2 is a constant, the derivative of 2 is 0. Now, where do we go from here? Well, from here, right, from here, we need to remember, we're trying to find, right? We're trying to find dy dx, because that's y prime, right? Y dx is y prime. That's what we're trying to find. Well, we have a dy dx right here, and we have a dy dx right here. So we're going to now do algebra. We're going to leave the dy dx's on the left-hand side, and we're going to move everything else to the right-hand side. So if we rewrite this, we have x squared dy dx. Here we have a negative. I'm going to distribute the negative because this also has a dy dx. So I have 3xy squared with a minus sign, 3xy squared. And I have a dy dx equals, and all the terms that lack a dy dx are going to get moved to the right-hand side. So what else do we have? Well, we have 6x squared here. That's going to be minus 6x squared now, right? Because when we move that positive 6x squared across, we're going to get a negative. Here's a plus 2xy. So we're going to move that over here, minus 2xy. We don't move this term because we already have that term here because it has a factor of dy dx. Here we have minus y cubed. So we move that across. That becomes plus on the other side, plus y cubed. Now we're almost done. We're trying to solve for dy dx. We know from algebra that if we're trying to solve for a variable and we have it in each term, we factor it out. So that would leave us dy dx times x squared minus 3xy squared equals, and I'm going to rewrite this with the positive term first, just because it looks nicer. And so we get this line here. This is our next line. Now, remember, we're trying to solve for dy dx. So to get it by itself, I'm going to divide both sides by x squared minus 3xy squared. That will leave me my derivative. I'm going to have a numerator of y cubed minus 6x squared minus 2xy divided by x squared minus 3xy squared. And that's my derivative. Often when we solve an implicit differentiation problem, our derivative is going to be expressed in terms of both x and y. And in this case, it was. We have terms over here that involve x, just x. We have terms that involve just y. And we have terms that involve the product of x times y. Right? So implicit differentiation, it's all about organization, patience, and just being careful. Right? We need to be careful that we don't miss any of the steps. All right, so that was number 6. Let's do another problem here. I haven't used that green pen in the last few videos, and I was wondering this morning when I picked it up, I wonder why I haven't used this green pen. It writes beautifully. Well, now I see why I haven't used the green pen. It doesn't erase beautifully. So we'll switch away from the green pen so we don't have to spend so much time erasing. Okay, so that was number 6. Let's take a look at something like number 12. Okay. Another very typical implicit differentiation problem. This one involves trig functions. So we are again asked to find dy dx. That's what the instructions ask us to do. So we're going to take the derivative of both sides with respect to x. So I'm going to take the derivative over here with respect to x of, and I have a product, right? I have y sine of x squared. Now over here, we're going to take the derivative with respect to x of x sine y squared. And again, just like in the previous problem, it's highly significant for us to identify that x is our independent variable. So when we do the product rule here, right, if we look at this as the product rule, this function is my f, this function is my g. So I have a product rule on this side. Again, I have a product rule. There's an f here times g. So we're going to do a product rule on the right and a product rule on the left. Now, when we do that, what are we left with? Well, the product rule, as we've written previously in this video, the product rule says to take the derivative of the first term. That's going to be the derivative of y. It's not 1 because our independent variable is x, times the second term, right? So that's sine of x squared. But we're not done, right? That's f prime g plus f. The derivative of sine, this is a composition of two functions. We're going to have to use the chain rule here. The derivative of sine says the derivative of the outside function first, that's cosine. We leave the inside function alone, and then we multiply by the derivative of what we find inside. The derivative of x squared is 2x. Now on the other side, we also have a product rule. First step, we take the derivative of x. Our independent variable is x, so the derivative of x is going to be 1. Again, we don't have to write it down, but for completeness, I'll put it there. Then we copy down, right, f prime g. We copy down the second term. Plus. We leave the first term alone. That's f. And now we take the derivative of sine. Once again, it's a composition of two functions. So the derivative of sine is going to be cosine. We leave the inside alone. Then we take the derivative of what we find inside. Now we got to be careful here. The derivative of y squared is going to be 2y. Right? We bring down the power. But then we have to multiply by the derivative of y. So we get 2y dy dx. And now we're faced with the algebra portion of this question. Just like before, there's going to be an algebra portion. When we look at this, right, we have one term with a dy dx here. We have another term with a dy dx here. We need to get all the dy dx terms on the same side so that we can factor and move forward. So I'm going to leave this term here, dy dx times sine of x squared. I'm going to bring this term across the equal sign, so it's going to be negative 2 xy cosine of y squared dy dx equals. Now we got to get all the terms without a dy dx to the other side. We have one here, sine of y squared, minus, because we're moving this term across, 2xy cosine of x squared. So now that we have it separated on both sides, we're going to factor out the dy dx, leaving us sine of x squared minus 2xy cosine of y squared equals sine of y squared minus 2xy cosine of x squared. Now, all that's left, of course, is to take this term and divide it over here. All right, so that's number 12. We didn't write with green, so let's see if this erases better. Oh, yeah, much better. Okay. So let's take a look at something like 17. Okay. 17 says we're given f of x plus x squared times f of x cubed equals 10. And we're told f of 1 equals 2. And they want us to find f prime of 1. So we're going to take the derivative of both sides with respect to x. Okay, just like we did the last problem. We'll take the derivative over here with respect to x of f of x plus x squared times f of x cubed. And over here, we'll take the derivative with respect to x of 10. Now, the derivative with respect to x of f of x is going to give us f prime of x. Here, we're going to have to use the product rule. So we get plus, this is my f, that's 2x. We leave this term alone, f of x cubed, plus, because that's f prime g. Now we have to do f, which is x squared. G prime is the derivative of this. So this is going to be our chain rule. So we're going to bring down the 3. And we're going to have f of x squared. But don't forget to take the derivative of what's inside, f prime of x. Now over here we get 0, because the derivative of 10 is 0. Now they've given us f prime of 1. Sorry, they've given us f of 1 is 2. So they want us to plug in 1. This would be f prime of 1 right here. We'll go ahead and write that in pink because that's what we're looking for. Here we'll have 2 times 1 times f of 1 cubed plus, we're plugging in 1 for x, but we're plugging in 2, right, for f of 1. We'll do that in the next step. So here we have 1 squared, x is 1, then we have 3, and then here we're going to have f of 1 squared, and then here we're going to have f prime of 1, and that's going to equal 0. So what do we end up with? Well, right now we have f prime of 1 right here. We're looking for that. F of 1, according to this, f of 1 is 2. So 2 cubed is 8. 8 times 1 times 2 is going to be 16. So that's going to give us 16. F of 1, right? F of 1 is 2. So 2 squared is 4 times 3 is 12. So this is going to be plus 12. 2 squared. I didn't do the 1 squared. So 1 squared is 1 times 3 is 3 times 2 squared is 4. 2 squared, 3 times 4, 12. That's where we get the 12. We have f prime of 1, and all of that is going to equal 0. So if we add these together, right? If we add these together, we have one of them here. We have 13 f prime of 1s. We move the 16 to the other side. We get negative 16, and so f prime of 1 equals negative 16 divided by 13. That's number 17. I'll do one more. I'll do something like problems 25. All right, we'll do 25. So problem 25 says use implicit differentiation to find the equation of the tangent line to the curve. So here we have in problem 25, we're going to find the equation of the tangent line. So we have x squared plus y squared equals the quantity 2x squared plus 2y squared minus x squared. And our point is 0, 1/2. And they want us to find the equation of the tangent line. So we know right now that the equation of the tangent line is y minus 1/2 equals the slope times x minus 0. And we have to find the slope, and that's going to be the derivative, right? That's going to be the derivative. So we're going to take the derivative of both sides here. Now, I'm not going to write the dx. We'll just do it. We've done 3 of these already. We did many in class. So the derivative of x squared is going to be 2x. The derivative of y squared, we're going to bring down the 2. We're going to get y to the first power, but then we have to take the derivative of what's inside, and that gives us our dy dx. Now, what are we going to do over here? Well, over here, we have a function to a power. So we bring down the power. It's the chain rule, right? So our new power is going to be 1. So that's going to be 2x squared plus 2y squared minus x. But we have to do the chain rule. We have to multiply by the derivative of what we find inside. The derivative of 2x squared is going to be 4x. The derivative of 2y squared is going to be 4, right? We bring down the 2, y to the first, but then we have to take the derivative of y, and we get dy dx. The derivative of minus x is going to be minus 1. So we did the chain rule, we brought down the 2, subtracted 1, and then we took the derivative of what's inside. Now, typically we would move the dy dx's to this side, move everybody else to this side. We don't have to do it that in this problem. In this problem, they've given us values for x and they've given us values for y. They've told us x is 0. So this is really 2 times 0. So that's 0. This is 2 times y. Y is 1/2. So 2 times 1/2, that's 1. So that's dy dx. So we're just plugging the numbers in as we go. That's 2. X is 0. 0 squared is 0 times 2 is 0. So that's going to be 0. Y squared, that's 1/2 squared. That's 1/4 times 2. So that's 1/2 minus 0, all to the first. And what do we have here? We have 4 times 0, that's 0. We have 4 times y. y is a half, so 4 times a half is going to be 2. And then we have our dy dx minus 1. All right. So what do we get when we clean all this up? Well, over here we have a dy dx. Here we have 2 times a half. That's 1. So that's just 1. And here we have 2 dy dx minus 1. So we'll move the 2 dy dx over here. That leaves me a minus, right? Because there's 1 there. We'll bring that over. We have minus 2. So that gives me a negative dy dx equals negative 1, or dy dx equals 1. And so the equation of our tangent line is y minus 1/2 equals 1 times x minus 0. All right. Go ahead and finish the rest of the problems here in section 3.5. This is the last section covered on our first midterm. All right. This is the last new material that will be covered on the midterm.